sorry, I'll try speak up. Yeah, so the first problem I want to go through is the first problem from the
Can you
Asia
please
Pacific.
share the Jamboard link again?
Yeah, does this work?
No, I think that you need to give it the access from that share thing. You need to click.
Change to anyone with the link can edit. Okay. Yeah. Okay. So no, there will be no coding. We're just going to like get the idea for the problems, because coding it's not that hard really. So yeah, it's first problem is from APIO 2011, problem 1. So it's called table coloring. And basically what this problem is about is you have a grid of cells. So let's say N by M. And all of the cells are either colored red or blue. So let's say red's like this, blue's like white. And the problem basically says that in each 2x2 cell, each 2x2 square, you have either 3 red cells or 3 blue cells.
Raghav, please mute yourself.
Yeah, Vikram did go through this, I think.
Can you just please mute Raghav? Yeah, okay.
So yes, Ratan did start with this, but he didn't finish going through with it, so he just asked me to finish. So yeah, for example, this 2x2 square here has 3 red blocks and 1 blue block, while this 2x2 square has 3 blue blocks and 1 red block. And now the problem is, okay, so some cells are already colored in either red or blue. And given these colored in cells, you want to find out how many ways are there to color in the rest of the table.
Could you please repeat the question?
Okay, so basically you have a big grid of n cells by m cells. So in this case, n is equal to 7 and m is also 7. So each cell in this table is colored either red or blue. And the condition is that in each 2x2 square, so for example, this square or this square here, there are either 3 red cells or 3 blue cells. So for example, here, this 2x2 square is invalid because it has 4 red cells and no blue cells. So the question is, given that some of the cells are already colored in, how many ways are there to color in the rest of the table? So just as an example, let's say you have a 2x2 table and one of the cells is colored in red already. So to color in the rest of the table, you can either have 2 more reds, or you can have 0 more reds. And so from the first way, there are 3 choose 2 ways to choose the 2 red cells to color in. And the second one, there's just 1 because you know that all of these have to be blue. So in total, there are 4 ways to color in this table if only the cell is colored in at first.
Aren't there 8 ways for this table? One for red and one for blue. 4 plus 4, 8.
No, what do you mean?
Why are you only considering the case when there is only one red? There could be only one blue.
Oh, because
Were
this one,
already filled in.
it's already red when you start it, so you can't change it. And that's why there are
So,
only
does this table have some already red cell?
Sorry, what do you mean?
In the start, is this table empty or does it have some red cell?
It has some red cells and some blue cells, or like none. So basically you're given the cells that are colored in already.
So the number of ways will vary if the top grid is empty.
Yeah, so let's start with the case where
Can you just clarify one doubt? Is the original table empty or not?
no, it doesn't have to be. It can be empty, but it doesn't have to be empty.
So wouldn't the answer vary for because of the table given to us?
Yes, so this is the table given to you. There is no blue. And the answer is 4 ways.
Okay, so what are we supposed to do? Like, are we supposed to find an general answer or an algorithm or like what?
You find an algorithm.
Oh, okay.
N and M are just like as big as you want them to be. It doesn't matter. So let's say, yeah, so N and M are arbitrarily large. So it doesn't matter what they are. And also, the number of colored cells is at most, let's say, 100,000.
If
So
possible, could you copy paste the original solution question?
Okay, let me just find that. Okay, so I'll send the problem in the chat now, but does anyone have any ideas so far?
Okay, so okay, I don't know a lot of coding, but I'll like give whatever I can get. So I mean, the most obvious is to just go through each cell from what do you call from the top and then go right, and then we could go through iterate through all the possible ones, go through one way and then iterate.
What's like?
Have you sent the question somewhere?
I sent it in the chat. Oh, sorry, I sent it as a direct message. Here it is. Okay, so
Thanks.
sorry. Okay, so sorry, what did you say again?
Me?
Yeah, about going through the cells.
Yeah, okay, so just a reminder, I don't know a lot of coding, so I might tell not nonsensical words, but you get the idea, right? So what I'm telling is that we could go through cells from top left and then scan through them and then go through each possibility. Some things are given, so already we have some matrix, I don't know. So already we have something definite, and then now we go through all possible ones one by one, one by one.
So check each 2 to the n plus m. I mean, 2 to the
But
m.
sir, if suppose someone had already colored 4 cells of a square 2x2 square already
Okay,
of
so
a
like
particular color, then aren't we can't simply do anything.
So are you saying if like they already colored it like this, then you won't be able to do anything?
No, if this red would all
If what?
if this red was also blue.
Oh, yeah. So
If this red was blue.
was blue,
I think
then
they'll
the
give a
answer
possible one,
would be
and
0.
answer would be 0. That happens.
Yeah, so there are 0 ways. And if the board is entirely colored incorrectly already,
Then
then
it's
the
1.
answer
Okay.
is 1. Yeah.
Okay, so like instead of 2 power nm, I think like we could like, okay, so like when we are iterating through each possibility, so cell 1, cell 2, cell 3, so on, if we find something is impossible, we just leave the way. So like I think it'll be lesser than 2 power nm, or for better efficiency, we could start with wherever the density of cell is more. I guess density of cell already given cells is more.
Yeah. But the problem with that is it'll still be really big. So we need
Yeah.
a more efficient way. So one way would be like, okay, if you're given 3 cells already, you know what the 4th cell is. So let's say let C of x, y equal to 1 if red and 0 if blue, right? So if we're given these 3 cells, then C of x, y is equal to the bitwise, or the logical knot of cx minus 1 y XOR c of x y minus 1 XOR cx minus 1 y minus 1, right? Does this make sense?
What is this weird plus?
Oh, it's XOR. So XOR basically is like 1 XOR 1 is equal to 0 XOR 0, which is equal to 0. But 1 XOR 0 is equal to 0. XOR 1 is equal to 1. So it's the exclusive OR. So only one of them can be 1.
Basically modulo 2.
Yes. So it's basically just modulo 2. So this is like a
And
recursive
what is
sequence,
this?
right?
Some L kind of in the starting.
Oh, this is not. So not 1 is 0 and not 0 is 1. Right?
Yes.
So does everyone agree with this formula? Yes, okay. Well, yeah, so this is the
Okay, so like
formula
I mean,
based-
I'm going to ask an
Yeah, this
obvious doubt,
formula
but
is fine.
is XOR associative?
Yes, it is.
Okay.
So yeah, basically I made a spreadsheet using this formula to show you what happens. So one thing you can notice is that the top cells, so this row of cells and also this column of cells, they're independent, right? So like if you change them, you change the entire rest of the board. So if you change this from blue to red, then the rest of the board changes, but these don't change. So this means you can define the whole board's coloring based on just these border cells, right? And so
Can you change
let's see.
A1 and B1 to red ones?
Okay. So if you change this to red and this one also to red, then that happens. So basically what happens is if you change one of these edge cells, so like these ones, B to Z, then it changes the column or the row that it's associated with. And it changes nothing else.
But this is not the curling original given to us, right?
It's not. It's just a spreadsheet that shows you what happens when you change these cells. So say you make this one red and these red, then it changes it like that.
Okay, so are you telling that if we start with this configuration and go through some changes of what rows and columns, we'll end up with any possible configuration we want?
Yes.
Okay.
So basically, you'll see that any cell, so let's say G9 here, it depends only on this cell, G1, this cell, A9, and A1. Because if you look at it, so let's add a border. Then if you change this one, it changes it. If you change any other cell, it doesn't change. And if you change the cell, it changes it as well. So this means you can basically define a cell's color based on this cell, well, the two edge cells, and also the corner cell.
I didn't get how the algorithm is working. Like, so when you change A1, then I can, so can you change A1 once?
Okay, if you change A1, then all of these cells here also change. So
Why are they getting
color.
changed like this? Like it might happen that when you color A1 red, then B1 also get colored red instead of B2 changing to blue.
Because
No,
if
like
you
we are
change,
controlling it. We are controlling what to
yeah,
change.
yeah. So what I'm trying to say is if you know the top row and you know the left column, then you also know the rest of the board. Does that make sense?
Okay, so like, but for that you have to prove that any configuration is possible with this algorithm. How do you prove
You
it?
don't. You don't need to prove that.
So we can go by
I'm just
recursion
showing
method
you.
also, right? To prove this, like if you
Sorry,
want.
what?
The recursion which you made, we can like solve it and then also do something to prove this, right? If you want to.
Okay, well, what I'm just trying to show you here is that any cell's color only depends on the cell above it, the cell to the left of it, and the corner cell. So, yeah, that means that if you know the cell's color, then you know that this cell depends on this cell. And so if you know that M13 is, let's say, red, then you know that either M1 is red and A13 is blue, or it's the other way around. Assuming that A1 is blue, right?
Okay, got it. So like essentially you're proving that all the cells colors are dependent only on the first
On
row,
3
first column.
cells.
Is that it?
Yes, exactly.
Okay, got it.
So let's see what this means, right? So since they depend on each other, like the top column and the top row also depend on the colors of the cells. So let's draw a graph, right? So this is the left column and this is the top row. So if you know that like say this cell is blue, then you know that this node depends on this node and vice versa. So basically, given this node's color, you can determine this node's color.
Why?
right? So
So like the
because
blue one
we
is
know
given,
that,
right? Is it a given one?
yes, this is
Oh, okay.
given. So that means if you know one of them, you know the other as well.
What about this? This is not. This is also required.
That one can be anything. So we don't really care about this right now. We can just change it, and then we'll have to change one of these.
Yeah. So basically, you multiply by 4, kind of.
Yeah, basically, you'll multiply by 4 at the end. But so what this means is if you draw the relationships between each pair of nodes that depend on each other, you get a bunch of connected components, right? So you get K connected components. And since each connected component is independent of each other, because like if this is blue, it doesn't really affect what this cell is. So it also won't affect these two cells. That means there are 2 to the k minus 1. There are 2 to the k minus 1 possible color rings. But there's also another part to this problem, which is where you check whether or not the answer is 0. And so how you do this is you basically look at the relationships between the things. So let's say this node is U, this is V.
Oh, can you
Let's
please
say
tell
this also.
what do you mean by K connected components?
Okay, so in a graph, you have a bunch of nodes and you can draw edges between them. So a connected component is just like a set of nodes where you can go from one to the other by only going on the edges. So in this case, there are 3 connected components. Does that make sense?
Yeah.
In which case?
Sorry, what?
The drawn, which we drawn for the example.
Okay, so I have a doubt. So when we are okay, so when we're telling that somewhere in middle there is some blocks whose color is given, then how can you say that it only depends on its column first and then row first? It's a corresponding column first and row first cell color. Like, wouldn't it depend on all above the column first, all to the left of column first, and all to the above?
No. So basically you have this recursive formula, right? And
Okay.
if you expand it, then you'll see that things cancel out with each other. So like
Oh, they
anything
cancel out.
resolved by
Acha.
itself is 0.
Oh. Okay.
So
Okay.
then
Got it, got it, got
eventually you
it.
keep going and you get
Okay.
this and this and this.
Nice.
So yeah, basically you do that and you get it's either 2 to the power of k minus 1 or 0. And to check whether or not it's 0, you basically have a bunch
Okay, so
of
one more
things
doubt.
like
Shouldn't it be 2 power k instead? Why is it 2 power k minus 1?
Oh, you're right. No, it is 2 to the power k. Sorry.
Sorry?
Wait, no, it's plus 1. Sorry, not minus 1. Because there's also
Acha, that
this.
is also there. Oh, yes. Okay,
Yes,
fine.
sorry.
Sir, could you please repeat
So,
definition of a connected component?
so a connected component is a set of nodes in a graph where each pair is reachable from each other via edges. So for example, this is a connected component because you can go from this node to this node, you can go from this node to this node, and you can go from this node to this node, and vice versa.
So wouldn't the answer, how can the answer be 2 to the power k plus 1? Because if we consider a special case when the first row and first column are colored, then we only have one component, right?
Sorry, what do you mean?
Suppose we consider the case when only the first row and first column are colored, then the answer is 1, right?
But so if you have like this,
No, only the full first row and the full first column are colored.
oh so
Yeah,
like
then like there are like no connected components then.
this.
Yeah.
Well, if this happens, then you basically we assume that you can't color in the first row and the first column because you can add an imaginary row like this. And if so if
What did
add
we
an
assume?
imaginary row. Oh, so I didn't mention this, but basically we assume that you can't color in the first row or the first column. And you can do this by adding an imaginary row and column like this. And the result is still the same, right?
Yeah.
So in this case also, in this 3 cross 3 grid also, isn't the answer 2?
So let's see. So this one is connected to this one. So this one is connected to this one, and these two are connected to each other. So there's so there's one connected component. And
Two
so
connected components, no? This one is also something.
No, we're only looking at these.
No, like that we don't know, right? That is the one that we don't know. Those three are the one that we know.
Yes, we know these. Okay, so basically, let's just draw it again. So each of these blocks is a node. Each of these is a node. Not these. These are just colored in. So this is colored in, which means that this depends on this one. So we draw a edge there. This one is colored in, so it's connected to this. And this one is colored in, so this gets connected to this. And so there are two connected components.
Which two?
So this one. So there's this one. These four nodes are connected. And there's this one.
But if the other four are determined, then this middle one will get determined automatically, this corner one.
Sorry, what?
Like if I determine the four blue things, then the green one won't get determined automatically. So why are we taking a power of 2 for it?
What do you mean?
In this case, what are you claiming the answer to be?
The answer is 1. Because we only care about this. We only care about this block. This is an imaginary block that we added. We don't care about the color of this. So the answer is 1.
And if I assume it was already there, if the table was originally 3 cross 3?
Well, then if it's like 3 by 3, then we just add another one. We just add an imaginary row and column.
No, and in this 3 by 3, we have just the above configuration like this, and this are colored in this 3 by 3.
Yes. So if this happens, then the answer is that this is connected to this, is connected to this. So these
Why are you adding
four-
an imaginary? We already have a corner thing right now.
Yes, but it's just easier to have a general solution if it's an imaginary column. So in this case, we have 4 connected components. So the answer is 2 to the 4 minus 2, which is 4.
Okay, so why is it k to power k minus 2?
Because like because there are k things and they're independent, right?
Okay,
So
yeah,
firstly,
there are k
they're
things that are independent.
So it's
Yes,
2 to
fine.
the k, but you also have to divide because firstly, this corner cell doesn't really matter because it'll never be, because like no matter what it is, it'll just flip all of these. And so we're double counting. So 2 to the k, you divide by 2 because of this cell. But also because like if you have one connected component like this, then there aren't 2 ways to color it. There's only one way to color it.
What?
So basically, let's say these are all red, right? So if these are all red, then there's only one way to color this, which is blue.
Yes, there's only one.
So that means if there's like k connected components, excluding this one, then there are 2 to the k minus 1 ways to color it in.
Okay, so that's my question again. Then why is it 2 to the power k minus 1?
Because like it just is. I'm sorry, like I don't really know what you mean. Can anyone help me out here? I think it has to do with this cell.
Sir, could you just wait for 2 minutes? Let me think of this.
Okay.
Andy, aren't the connections in this first one wrong? Like, shouldn't it be this to this? And this is correct. And
Yes.
this one to this. I
Yes,
think
so,
you did a bit wrong.
Let me just draw them again. So this one connects to this one, right?
Yeah.
And this one connects to this one, like this.
I think it's correct.
And this one connects to this. Like this, right?
Yeah, so maybe got confused with the intersection.
Yeah, sorry about that. Yeah, so the answer is just like that. And yeah, to check whether it's 0.
Okay, so maybe I got it. Why is 2 power k minus 1? So like for a cell to be one color, there are 2 possibilities, I think, for the respective column and row. Is that right? So like for a specific color, like let's suppose red, then both could be red, both could be blue. Something
Yes.
similar to that. So like then
So
we're
you
double
could have,
counting, I
like,
think.
so you could have like red, blue, or blue, red, and each of them are the same, right? Is that what you're saying? So since we counted this
Yes.
twice,
So there's double
we
counting, I
have
think.
to
Okay.
divide. Okay, yeah, that makes sense. Thanks.
Okay. Got it.
So to show that, to check whether it's 0, basically you have another graph that's like A is some color. So let's say blue. So this implies that like B is some other color, let's say red, which implies that C is some other color, and so on. So you basically have a graph like this. And to check whether it's 0, you just have to check whether there's a contradiction. So if this A is red implies that A is not red, then you know that this is a contradiction and the answer is 0.
Answer would be 0, right? Yeah.
So like we basically find a way that after we create the new imaginary row, that if one thing is determined, the other is also determined in a particular configuration. But how can we prove that there is no such a determining function in any other way? Uh, um, like how to prove this? We just prove that there will be connected components like that, and we say that the answer is this. But I didn't get this really.
You don't get what? Sorry? What?
Could you show your that Excel thing once again, please?
Okay.
Uh, and can you just explain that changing thing?
Okay, basically if you change a top row cell, so let's say you change this to red, then only this column gets changed, right?
Yeah.
And similarly, if you change a column, then only this row gets changed.
Can you go do this again? What happens when you change it A6?
So if you change A6, then see it's red, blue, but now it's blue, red.
Oh,
So it just flips all of the cells.
okay. And after that,
And after that, you can see that you can see how the recurrence works. So basically, or like not how the recurrence works, how this cell, let's say K9, only depends on K1, A9, and A1, and also its row and column count. Because you
what
see here,
happens
it's
if you
like
change A1?
A1 changes the whole thing.
It flips the whole thing.
Oh.
Okay. So can I move on to a different problem?
Sir, can you just say, so how are you defining that path thing? Like this is just an intuitive thing that this depends on this, but how to prove that some particular thing
Yes.
doesn't depend on any other thing?
Okay, so it can depend on other things. So let's say you have a graph like this, right? Let's say this is the graph. So this is colored in, this is colored in, and this is colored in. So basically what you can do is first number them 1, 2, 3, 4. And now you just double the graph. So you have 1 is red, 1 is blue, 2 is red, and 2 is blue, and so on for all of the nodes. And so
Wait, I think his question was that how can you prove that except for the connected components, it doesn't depend on anything else? I think that's what his question was.
Yeah.
Arjun, could
it
you?
doesn't depend on anything else, because if you expand this recurrence, then you'll see that cxy is equal to, I think, not c of 1 1 XOR c of 1x XOR c of x1 c of 1y XOR x times y mod 2. It's something like that. But you get this from expanding this recurrence out.
What do you exactly mean by expanding?
So cxy is equal to this, and this is equal to something else. This is equal to something else, and so on. And if you just do that, then you get things that cancel out, because 1 XOR 1 is equal to 0 XOR 0, which is 0. So the same thing XORed by itself is 0.
And how to prove this thing you have written?
You just expand it out, just like use induction, basically. And basically the spreadsheet just showed you that visually. I'm not going
Okay,
to
so like Arjun, like you don't even like have to use notation, like just logically you can, I think you can induct it.
Yeah, you can just use mod 2 if you want.
Yeah, you can induct that.
And how can one conjecture this very tough equation, that this is might be true?
Basically, you try to spot a pattern like this, and then you get this conjecture, and then you try prove it using induction.
So that visual proof was not a regress thing.
Sorry, what?
So was that visual proof regress in itself, or does the regress proof consist of proving this recurrence by induction?
It involves proving this by induction, but this is just so that you can see the pattern. It's not a proof.
Oh, okay. Got it.
Okay, I'll move on to the,
By the way,
I wanted to go, yeah.
why did we divide by 2 to that 2 to the k minus 1 thing for the A1 cell?
Because basically you can have double counting. So if this is blue but this is red, then this is something. So let's say blue. If this is red and this is blue, then this is still blue. So
No, I
you
think
only...
I think he was telling about A11.
Oh, this.
Yes.
Okay, so basically the color of this doesn't really matter, because if it's blue, then
Yeah, so
it
like
just...
if you were to change A11 and every row, like sorry, first row and first column, you'll get the same exact what do you
if
call
you make
configuration. So you're double counting.
So if you make this, if you make
Yeah.
all of these red, then it's the same as if all of them...
That is the exact same. So like,
Oh, okay.
so like double counting. So that's it.
Yeah. Okay. So I think now let's just go through an easy one. So you have a list of integers. So n integers between 0 and 10 to the 18. And basically you have a device that lets you query the smallest and largest of those numbers in the range. And you want to find the largest gap between two consecutive numbers. So the first question is, if each time you use the device you pay 1 rupee, how can you find it if you only have n plus 1 over 2 rupees?
The range should be till n minus 1, I guess.
Say what?
I think there should be minus 1 here.
No, because it's a strict inequality. Yeah.
Oh, sorry.
it's a strict inequality, so that's why. So anyone have any ideas?
Okay, so like let me think for like 2 minutes.
Also, just a fun fact, question 2 was the 1 mark subtask in IMO 2020, problem 6.
Oh,
What did
Well,
you
the
say?
idea is similar. So question 2, each time you use the device, you pay k plus 1 rupees, where k is the number of those elements within the range you're querying, and you have 3n rupees. So the idea behind this solution is the same as the idea behind getting 1 mark in IMO 2020 problem 6.
The combo geo, combinatorial geo one.
Yeah,
I
very
see.
similar idea.
I see.
In the first, like the n plus 1 by 2 rupees one, I think our strategy should be like we provide such L and R in the first go, such that we get A1 and A2. Yeah, and then in the
So what do you mean?
so in the first go, our L and R should be somewhat here.
But how do you know that they exist, those? Like, what if the numbers are like here? Then your query doesn't get anything.
So like between, I mean only the first 2 elements should be between our L and R in the first case.
But you don't
Sure.
know what they are.
Yeah.
If possible, could you again please send the link of the original question?
Okay.
okay. So like I think what we could do is uh, uh, okay. So define some. Okay, so we define some length x that we are iterating through. So like from 0 to x, then x plus 1 to 2x, and then so on. We just chose something random for now. Afterwards, we can optimize. Then find the probability that how the probability that number of the number of the numbers will be there in that the gap that will be there in that, and then optimize it maybe, and then get something out of that.
But how can you always like be sure that you'll find the answer?
So like maybe after optimizing, you get that it like you will get it surely for this x specific x, you will get it or something.
Like maybe you can, but there is a deterministic way. Okay, so basically, I'll give you a hint. The first query, you query 0 and 10 to the 18, because you know that all of them are in this range, right? So if you query this, you get the smallest and the largest. So what can you do with that information?
Could you show that screen once? No, that question screen. Okay.
Okay, so like if you were to query and we get that, we get the max to be like the, what do you call, the range over n, I think. Right. So like by pigeonhole principle, we get max, that is the range that we get out of the query over n, right? Or n or something, n minus.
What's the gap is greater than or equal to max minus
Is it right?
over 2. I mean, n. Is that what you're saying?
N minus 1 maybe. Wait, n minus 1. Right?
I think
Yeah.
that's right. So yes,
Okay.
that is the. So that's the main idea for the second question. The first question is much easier. Basically, you query this and this, and you get the endpoints. Then you query this, you get these. Query this, you get these, and so on. So then in n plus 1 over 2 queries, you can get the whole array. And using that, you can just find the largest gap between them. So question 2 is much more complicated. And so you've already said that the gap is greater than or equal to the max minus the minimum over n minus 1.
Sir, could you explain question 2 once, part 2 once?
Okay, so basically, let's say, okay, let me just draw it out. So let's say you query a range like this, right? So there are 4 numbers in here. So this query means you pay 5 rupees. And if you query it
over
into
2, I
a-
think.
No, just pay plus
N
1.
plus 1 over 2, I think.
No, that's the different one. But what are you asking?
Sorry, I could not hear.
What are you asking? Question 2.
Sir,
I mean,
could
I
you,
didn't ask. Somebody else asked.
sir, could you please quickly go through the solution of part 1?
Oh, okay. So part 1, basically, let's say you have these numbers. So the first query is you query 0 and 10 to the 18, because you know that all of them are in this range, right?
Yeah.
So this query gives you A1 and AN. The next query is you query A1 plus 1 and AN minus 1. And that gives you A2 and AN minus 1. And then you can just continue querying like that until you get the whole array of numbers. So basically you query until you know all of them.
Oh, got it.
And
Thanks.
so if you know all the numbers, then you can just easily compare them with each other and find the largest gap.
How do
Okay,
you
so like,
query
I mean,
this?
How do you what?
How do you query the second time? Like you don't know the how much is that the difference?
Well, you know A1 and you know AN, right?
No, like but the range we had was included like closed brackets. So
All are integers.
They're all integers. Yes. They're all integers.
yeah, so like, I mean, if you query a plus 1, obviously it cannot, there cannot be exist some integer between a and a plus 1, right? So like, obviously you will not lose anything. That's what he means.
Yes.
no, like when we query a2 and an minus 1, then the result would be a2 and an minus 1 again, and we won't be
No,
able
that's
to
what
get it.
No, like we're
A2
not
plus
querying that, we're querying plus 1. So we're not including.
You query this.
Oh, they're integers.
And could you explain the second question now?
Okay, the second one is basically you use this fact that the gap is at least the maximum minus the minimum over n minus 1. So the first query is you query 0.
No, can you explain the question?
So each time you use the device, you pay k plus 1 rupees, where k is the number of AI in the range you're querying. And you have 3n rupees. So for example, let's say you query, okay, let's use this example. The first query here would be, the first query would be 1, 2, 3, 4, 5, 6 plus 1 rupees. Your second query will be 1, 2, 3, 4 plus 1. So 5
Okay, I
rupees.
think it might be better if you were to write in like general n terms.
Sorry, what?
So, like you are writing for the special case of n equal to 6, right? So I thought it
Yeah.
might be better if you were to write in like general terms.
Yeah, no, I'm writing for the specific case.
No, let's
Okay.
first understand special only. Yeah. Yeah. After this,
Okay, so yeah, that's how the queries work, and you have only 3n rupees.
but I think this could exceed 300 rupees.
Yes, so that's why the solution doesn't work. You need a different strategy. So, yeah.
Okay, so like we know, okay, so first after the first query, we know that the maximum gap is at least max minus min over n minus 1. So instead of
Yes.
querying +1, why don't we query that gap? So like we reduce the gap by that maximum gap.
Yes.
Yes,
So
so like
let's
if
say you have so you break it into blocks like this and you query that, right?
yes,
But the money we pay is the same every time. So how does that matter?
no, I mean it could like it will decrease. So like we're not doing +1 each time.
Yes, so there are n minus 1 blocks. And each block is equal to an minus a1 over n minus 1, right? And yes, so this is the solution. You basically query these
Oh, that's
blocks
it.
because,
It does it.
yeah, basically, because you know that the maximum gap must be between blocks.
But we need to
yeah,
prove
that's-
that we will not pay, like we will pay less than 300 rupees, which is not at all clear.
Yeah, like I mean it seems kind of probabilistic. So how do we prove that we'll not pay
It's
more than
not
3?
okay. So the first query, where you query 0 and 10 to the 18 is equal to n plus 1 rupees, right?
Hmm.
And then if you look at these queries, each of these numbers is included in exactly one of the each of these numbers is included in one query. So if you add them all together, then you have to pay n rupees. But also for each query, you pay an additional 1 rupee. And since there are n minus 1 of these blocks that you query, you pay n minus 1. Then n plus
So
1
are you
from the
claiming
first.
that within 300 rupees I can determine everything A1 through AN?
You can't determine everything, but you don't need to. Because if you have a bunch of things in here, you know that the gap between these two and these two are
Yeah,
going
so
to
like
be
we
too
don't need
small.
them, right? So like gap is anyways less
Yeah.
than an minus a or whatever.
Yeah, you only need these gaps between consecutive blocks.
Now, sir, could you just wait for 1 minute on this slide? Just 1 minute.
Okay. So yeah, the cost in total is n plus 1 plus n plus n minus 1, which is 3n.
How is the cost equal to this?
Sorry, could you repeat that?
How is the cost equal to this n plus 1 plus n plus n minus 1?
Okay, so the first query where you do 0 and 10 to the 18, since all of the numbers are in that range, you pay n plus 1 rupees, okay?
Yes.
So that's where this comes in. The n rupees here is from each number being included in exactly one query. So for example, like each number contributes 1 rupee whenever it's queried. So let's just write it out. So cost is equal to sum of the times AI is included. So where I ranges from 1 to n plus the number of.
Okay, so like, do we know when our rupees are being like like what do you call deducted? Like, do we know how many rupees are being deducted each time? Do we know that?
No, you don't. You don't. But it doesn't matter. Okay, so yeah, the first query, costs n plus 1 rupees. And then in the second part where you query blocks, each number is included in exactly one block. So, and there are n minus 1 blocks. And plus n minus 1 rupees that you pay.
Sir,
So in
suppose
total, 3n.
the numbers given to us were 1, 3, 5, 19. Then what are we doing?
Okay, so 1, 3, 5, 19.
Oh no, like dots,
So,
like all odd numbers between them.
oh, okay, so basically query 1 returns 1 and 19, right?
And we pay 10 rupees, 11 rupees. Rn is
Yes.
equal to 10 here.
Yes. So 11 rupees.
After
Then
that, we tested 3 and 17.
what? No.
We had to
This is the
test 3
second.
comma 17, right?
No,
No,
that,
this
which
is
method? First or second? First problem or second problem?
Second.
No, but we're not
yes.
doing that. We're doing blocks stealing, right?
So the second one would be, okay, so 19 minus 1 over 10 is equal to 1 comma 8.
Wait, no,
I
it was
think 10
9, I
minus
think.
1. 10 minus 1
Yeah, 9 it will be. Yeah.
Oh, minus 1, which
is
is
equal
equal
to
to
2.
2.
2.
So this means you query in blocks of 2. So you query 1, 2, 3, 4, and so on.
No, like 1, 2, I think 1, 3, 3, 5.
1, 3, 3. Oh, yes. 3, 5, and so on. So in total, there are 9 queries because we query up to 17, 19.
And in each query, we pay 3 rupees.
Wait, no, it's 1, 3, 4, 5. Because you don't have to query a number twice.
So it should be 2, 3, 4, 5 maybe then. Why waste here also?
Okay, 2, 3, 4, 5. That's also fine.
Like the gaps have to be of 2. You are taking 4, 5, which is have gap only 1.
No, like I think it gap means like what do you call plus 1. So like number of things between them, including those.
It's not, I think.
Could you write
Okay,
this
so like I
below thing
mean,
again?
so like this was in like what do you call yeah, like okay, so like no, we cannot say that an minus a1 over n minus 1 is going to be an integer always. Like this was all like I think very vague.
Yes, but
Like I mean,
it
I
doesn't have
think
to be.
some things need to be settled, like the edge
It's
cases
at
and
least
everything.
this. And it's actually at least this.
Yeah.
So you can make it always an integer.
Okay, and then also in the each query, are we like when you say the gap is that, do you say the like the what do you call including both or excluding both or what?
What do you mean?
Sir, aren't 3 and minus 1 rupees will suffice?
Yes, but the whole point is like you have to do it in at most 3n. And since you do it in 3n minus 1, that's also fine.
Oh yeah.
Okay, so does that make sense?
Yes.
Cool. So I think unfortunately we're out of time, but I have 6 problems that I found online, and they're basically in increasing order of difficulty, kind of. And I'll send them in the Discord server so you guys can try solve them. So I've solved all of, so you guys can ask me for help for all of these except for problem 6. I haven't solved this one yet. And I actually don't know anyone who has, so yeah.
Like,
Guys
does
can
this
try
problem not have official solution?
No, it doesn't, because it's an old problem. So
Okay, so it's like, has nobody solved this or has somebody solved this?
no, people have solved it, but I don't know anyone who has, like, who has
Oh,
proved
okay,
it.
that's rare. Okay, fine.
How is 2015 old?
So sir, is the fifth problem greater than IMO 3 or less than IMO 3?
I'd say that this is probably just slightly less than IMO 3.
And
This
was
this is
and
I
is the
think this
sec
is harder than. Sorry, yes.
and is the second problem greater than IMO 2, less than IMO 2, according to you?
Less than IMO 2.
Okay.
It's like IMO 1, IMO 2, and then IMO 3.
Okay. And could you, like, how should we contact you, through Discord, email,
Just ping me on Discord.
your ID?
I am Dalton Garlic. So
Could not hear what?
Okay. Anyways, when you will send, we can message you.
Okay. Yeah. Cool. Okay. Thanks for coming, everyone.
Thanks for the
Thanks for
class,
the
sir.
class.
Should I end the stream?
Thank you. Yes.
When do we have the next class?
That should be at 9.
ठीक है.
Okay, thank you.
Bye.